Hey, welcome to Notes 1.1. Um, so statistics is really just the science of how do we collect data, how do we analyze it, and how do we make conclusions from that. Um, a lot of stuff is going on now with coronavirus and statistics. It's kind of interesting stuff. Um, So first of all, we're going to start off with some basic definitions. Okay, so here's the scenario. We have different kinds of roller coasters, what type they were, the height of them, design speed, and how long the ride was. My favorite, on the side note, the Griffin at Busch Gardens is my favorite one. I enjoy roller coasters a lot. Anyway, most data. Um, anyway, by looking at this, we're going to define what are the individuals and what are the variables. Okay. An individual is a person, animal, or thing described in the data. So in this case right here, our individuals are the different types of roller coasters. Okay. Well, not types, the different names. So Wildfire, the Skyline, the Goliath, the Helix. Okay. Those are all different roller coasters at different places. The variable is what attribute do we have for these different things? So we've asked about the type of it, the height of it, the design of it, the speed, and the duration. Those would be the variables that we're talking about there. Um, okay, so then when we're looking at these variables, we also have to want to know, are they categorical variables or are they quantitative variables? Okay, a category, if you think about putting things into categories, um, just think about that definition versus quantitative is a number value. Okay, so if you think about the variable of type, okay, they can either be wood or steel. That's a category. Okay, they're going to either fit into the wood or the steel category. The height can take any number value here. So this would be a quantitative variable. Design, it's either a sit down or an invert, or I guess that's the only ones I have here. So they once again fit into a category. So design would be a categorical variable. Speed, okay, once again could take any kind of number value. We could find the average speed and so forth if we wanted to. So that would once again be a quantitative. Duration, a number value, and quantitative. Now, just because it's a number value doesn't always mean that it's going to be quantitative. For example, if you have a zip code, I live in 22802. Some of you might live in 22801. So those are categories. I live in this category, you live in that category. Even though they're variables, they're numbers, they're still categorical variables there. Okay, so if you think about this here, here's another. They collected data about primary and secondary school students using surveys, and they did a random sampler to choose 40 U.S. high school students to compare their answers here. Okay, so we had different states and their level and their gender and so forth here. Okay, so I want you to pause the video and think about what would be your individuals and what would be your variables, and for each variable, is it either categorical or is it quantitative? Okay, pause the video and do that. Okay, welcome back. So our categories are the individual people. Okay, they surveyed 40 U.S. high school students who completed the survey, and then the variables would be all these different state, gender, all these things here. Okay. So state would be a category. Grade level would be a category, even though it's a number, it's still a category. Gender, category. Age, quantitative. Okay, because we're thinking any number there we could find an average to. Birth month, category. Height, okay, it's a numbered response. That would fit a quantitative. Arm span is a distance, quantitative again. And preferred status, they asked them, would you rather be rich or happy or famous or healthy? So that also there is a category people are being put into. By the way, feel free to pause this video at any time and take notes. Okay, so then we're going to talk about the distribution. So the distribution talks about what does it look like? Okay. Um, is it really spread out? Is it not very spread out? Is it together? That sort of idea is the distribution. Okay. So we can look at that distribution. We're going to, in the next couple of days, look about it, how to describe those in a couple different ways. Today, we're going to do frequency tables and relative frequency tables. Okay. So in that last problem, they took those 40 students and they asked them, would you rather be rich, famous, healthy, or happy? Okay. And here are those 40 responses. Okay. Now, frequency means how often something occurs. So one way to do that is to think about your 4 categories they could be in, and do tally marks as you go through the data. Okay, then a frequency table would be taking those tally marks and giving me the number of how many are in each one. So of those 40 kids, 7 of them wanted to be famous, 21 of them wanted to be happy, 4 healthy, and 8 rich. Total of 40 then altogether. Okay, so that's a frequency table, how often something happens. The relative frequency, when you think about that relative part, that means putting it into a percentage. So the famous were 7 out of the 40. Okay, so we're 7 here. 7 out of the 4, which comes into that percent, that as a decimal, which, if you remember, you move the decimal 2 places to turn it to a percent. Okay, happy was 21 out of the 40, which divides to be that, which turns to that percentage. So these percentages are the relative frequency. And altogether, they should add up to be 100% of your data.